This video is for November 14th, November 15th, and we're looking at continuing to simplify trigonometric expressions. Specifically, these types of trigonometric expressions, most of them deal with getting a common denominator. And so I'll probably talk through two of these, and then the other problems are similar, and I will post those solutions online. So let's talk about this one here. We have sine, cotangent, cosine. We already have sine and cosine, so maybe it would make sense to turn cotangent in terms of sine and cosine. Just a reminder, tangent is sine over cosine. Cotangent is cosine over sine. So let's go ahead and do that. Let's turn this to cosine over sine and see what happens. If we want to continue down this road, then we can multiply these two guys here. We could put this over 1. Cosine times cosine would give us cosine squared. Sine times 1 would give us sine. Okay. Now, the thing here, though, is if we're adding, this is a fraction, this isn't, we can make that a fraction by putting it over 1. But we still can't add these because we don't have a common denominator. So if we wanted to add these, we could by creating a common denominator. Now, the thing here is this denominator already has sine. It would be great if we could give this denominator sine as well, and we can. We can multiply this denominator by sine. Now, the only thing is, if we multiply the denominator by sine, we also have to multiply the numerator by sine. So this is getting, creating our common denominator. I'm just going to write creating common denominator. Also, the reason why it's sine over sine is because that equals 1. If we can multiply anything by 1, that's itself. So we can multiply this and it doesn't change the value of the actual expression. Now, if we were to do this, sine times sine, that gives us sine squared over sine plus cosine squared. Now we have a common denominator. We can add these fractions. We do that, you add the numerators, but they're not like terms. So we can just write that as sine squared plus cosine squared all over sine. And then if we look at our Pythagorean identities, there is an identity that says that sine squared plus cosine squared equals 1. So because sine squared plus cosine squared equals 1, then we can replace this with 1. And all of that becomes cosecant of x. The two big things, the two big concepts here, the first one here is getting the common denominator. Here, we could try to get a common denominator by multiplying the denominator by sine. We could do that as long as we multiply the numerator by sine as well. Also here, using the Pythagorean identity, sine squared plus cosine squared, to replace that with 1. And then this is using a reciprocal identity. If you don't have those identities in front of you, it's going to be really challenging to maybe keep up with this. So I would recommend keeping those identities in front of you so you can refer to them and see what how we're doing this, how we're changing certain things using the identities. All right, let's go ahead and do the next one, and then I'll post all the solutions online. That's essentially what we did in class. We did 1 or 2, and then the rest of the time in class we worked on the problems, see if we can ultimately come up with those equivalent expressions. But here, this negative x, we always want to get the negative outside. Sine is what we call an odd function. So we can use an even odd identity here. That's going to move the negative in front of sine. So we can really make that positive, turn that to minus. Also here, we're going to want to turn that to x, and we can using a cofunction identity, then that would become tangent of x. Okay. Now, what can we change? Maybe change secant. We know using the reciprocal identities here that we can change secant into its reciprocal in terms of its reciprocal as 1 over cosine x. I'm just going to do it piece by piece, kind of let you think, go through what I'm thinking. So I see that I have cosine in the denominator here. I have it in terms of sine. Now the thing is, I can turn tangent into a couple things. I can turn tangent into 1 over cotangent, or I can turn tangent into sine over cosine. Now if I turn it into 1 over cotangent, that means cotangent would be in the denominator. I have cosine here, so that might complicate things. If I turn tangent into sine over cosine, then I have cosine in the denominator here. I have cosine in the denominator there as well. So that seems like the better route to go. So let's change tangent into sine over cosine. Now, if I multiply here, we would have a common denominator, which is what we want. I'm going to divide this so I know where to stop. So let's go ahead and multiply sine times sine. That would give us sine squared. All right. Now we have a common denominator. We can subtract those two fractions. Oh, nope. That will leave us with 1 minus sine squared in our numerator. When we subtract fractions, the denominator doesn't change. Now we have to look at our toolbox and see, is there anything in our toolbox that we can use to help simplify, to change this expression in a way that helps us simplify? And we can. And what we can do here is use the Pythagorean identity. I'm going to just write it without the x's. And we want to change 1 minus sine squared in a way, the Pythagorean identity in a way that we can get 1 minus sine squared. Well, here I have the 1. I want the sine squared to be negative, so maybe if we subtract sine squared, those go away. And we'd be left with 1 minus sine squared. That's what we have here. That's what I have there. It's equal to cosine squared, which means that I can replace 1 minus sine squared in the numerator with cosine squared because they are equal. And then if it helps you to see it here, I have cosine squared, which is something times itself. And then these would divide out and we're left with cosine of x. Okay, in the first problem, we had to create the common denominator here. In the second problem, when we change things in terms of sine and cosine, a helpful tool, not always helpful, but sometimes, we already had a common denominator. That was here. We already had the common denominator of cosine, so we did not have to create that common denominator. However, once we did that, we did need to manipulate the Pythagorean identity here to replace 1 minus sine squared with cosine squared, which helps us simplify to just get cosine. Okay. If you have questions, if you need to rewind, pause, whatever you got to do, you can ask questions through email, through the Remind app, through the website. Highly recommend you asking questions if you don't understand where certain things are coming from, how we can simplify things like that.